Welcome viewers. I am Disha Dhabarde from Kamla Nehru College of Pharmacy, Buttiburi, Nagpur. Today I am going to present Introduction to Infrared Spectroscopy. After watching the video, the viewer will be able to know region of infrared in electromagnetic spectrum, explain why wave number is used instead of wavelength, principle of infrared spectroscopy, know the significance of fingerprint region. Now the introduction. The electromagnetic spectrum is the complete spectrum of all forms of light. This infrared region means light having a longer wavelength and lower frequency than visible light. The electromagnetic spectrum consists of radio waves, microwaves, infrared waves, visible light waves, ultraviolet waves, X-ray waves, gamma waves. Infrared spectroscopy deals with the infrared region of the electromagnetic spectrum. Infrared waves are invisible electromagnetic waves that are detected as heat. It contains higher energy than microwaves but lower than visible light. Infrared spectroscopy is also called vibrational spectroscopy as it is technically based on the vibrations of the atoms of a molecule. It is an interaction of infrared radiation with matter. Question: why in infrared spectrum wave number is used rather than wavelength? Answer of this question is it covers the range of electromagnetic spectrum between 0.78 and 1000 millimeter. In infrared spectroscopy, wavelength is measured in wave numbers which have the units centimeter inverse. The most useful infrared region lies between 4000 to 670 centimeter inverse. In IR spectrum, peaks are very closed. We can use wavelength to represent IR spectrum, but sometimes it becomes two closest peaks on the wavelength scale. For example, if one band occurs at 37,020 centimeter inverse and other band occurs at 37,030 centimeter inverse, then the two bands are 10 centimeter inverse apart from each other. But if we convert these wave numbers into wavelength, then first band will occur at 270.12 nanometer and other band will occur at 270.05 nanometer. On the wavelength scale, both bands are 0.070 nanometer apart from each other. Thus, 10 centimeter inverse difference is more convenient than 0.070 nanometer difference. Therefore, in IR spectrum, wave number is used rather than wavelength. Principle: when the energy in the form of IR is applied and if the applied IR frequency is equal to natural frequency of vibration, the absorption of IR takes place and a peak is observed. When molecules absorb IR radiation, they are excited to reach to the higher energy state from the ground state. When a compound is exposed to IR radiation, it selectively absorbs the radiations which produce vibration of the molecules of the compound. This results into absorption band which is called as IR absorption spectrum. The bands corresponds to the characteristic functional group. The absorption peaks within this region are usually sharper when compared with absorption peaks from the ultraviolet and visible region. This IR spectroscopy is very sensitive to determine functional groups within a sample as different functional group absorbs different frequency for particular IR radiation. Therefore, it is used to determine the functional groups of molecule. Thus, an IR spectrum of a compound is considered as the fingerprint for its chemical identification. Each molecule has a characteristic spectrum called as fingerprint region. Another question, what is the significance of fingerprint region in IR spectroscopy? Answer for this question is the region between 400 cm inverse and 1500 cm inverse in an IR spectrum is known as fingerprint region. The pattern in the fingerprint region of a given compound is unique and therefore be used to identify individual peak. Each compound has a unique set of tropes within the fingerprint region that can be used to identify the molecule. This region contains a large number of stretching and bending vibration. When a molecule is in the ground state, it possesses three energy levels: electronic, vibrational, and rotational. Absorption is due to changes in the vibrational and rotational energy levels. When an electron absorbs less energy, rotational transitions takes place. This spectrum is called as rotational spectrum. This rotational spectrum is observed in far IR region. When the electron absorbs still higher energy, vibrational transitions takes place, which accompanied with rotational transitions. The resulting spectrum is called as vibrational rotational spectrum. This vibrational rotational spectrum is observed in near infrared region. Electronic transitions takes place at higher energies. These are not seen in IR region. This is all about the introduction of IR spectroscopy. Thank you for watching the video.